Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, we will be tackling a question on rates of reactions. Please note that this is question number 7. Please do expect a total number of 11 questions, and all of these questions will have their own videos. And also please note that they are all extracted from past exam question papers. And it's very important for you to know how to tackle such questions, because it will give you an edge whenever you write your exam. So please do share the video to your peers so that they may have the same edge as you do. Okay. Learners use the reaction between sodium thiosulfate and hydrochloric acid to investigate one of the factors that affect reaction rate. The balanced equation for the reaction is given below. We do have a sodium thiosulfate reacting with hydrochloric acid, and then the products that will be formed, we have sodium chloride, water, sulfur dioxide, as well as sulfur. Okay, excuse me. And then we are told that okay, the diagram below shows the experimental setup. We do have our flask, and inside our flask we have our reactants, which is sodium thiosulfate as well as hydrochloric acid, and then underneath the flask we have our white paper. And then we are told that in the first experiment, 50 cubic centimeters of sodium thiosulfate solution is added to 100 cubic centimeter of a 2 mole per cubic decimeters of dilute hydrochloric acid in a flask that is placed over a cross drawn on a sheet of white paper. The hydrochloric acid is in excess, okay, which simply means that sodium thiosulfate will be used up completely. The time taken for the cross to become invisible, the time taken for the cross to become visible when viewed from the top is recorded. The experiment is then repeated 4 times with different volumes of sodium thiosulfate. The results obtained below are shown in the table. Okay. Okay, firstly they want us to define a rate of reaction. Nah? They want us to define a rate of reaction. A rate of reaction, guys, is just the change of products, or rather the change of concentration per unit time. Nah? The change of the quantity of products per unit time, or the change of the quantity of reactants per unit time. And then now we are being asked that how does the concentration of sodium thiosulfate solution used in experiment 2 compare to that used in in experiment 5? Choose more than, less than, or equals to. Okay, in experiment 2, the concentration is more. Why? This thing is the same as if let's say you wanna mix Oros with water. Let's say you start by pouring water inside your Oros, né? But then you wanna make an orange juice, and then you decide to pour Oros. If you pour the smallest amount of volume of Oros, do you agree that the concentration of the Oros that you've poured will be smaller? But if you pour a greater amount of volume, the concentration of your Oros will be more as well. Are you together? So this simply means that wherever there's more volume of my sodium thiosulfate, the concentration is higher. And it makes sense, because if you can check over there, for experiment 2, it will take only 28.6 seconds for the reaction to reach completion. Are you together? But for experiment 5, with the smaller volume, that means I have a smaller concentration of my sodium thiosulfate, I will take 111.1 seconds for the reaction to reach completion. Are you together? So the concentration will simply be more than. Okay, now they want us to draw the average reaction rate versus volume of sodium thiosulfate on the attached graph, on the attached graph sheet. Né? Since guys, I told you that these papers are these things are extracted from past question papers, ne? I will go to the question paper and check for the diagram sheet. Okay, let me just take these points. When the volume is 50, what do they want us? Average reaction rate. Okay, the average reaction rate will simply be 4.4, and then when the volume is 40, average reaction rate is 3.5. When the reaction is 30, when the volume rather is 30, average reaction rate, that's 1.7. And when the volume is 20, average reaction rate, that's 1.7. When the volume is 10, average reaction rate, that's 0.9. Okay. Let me go to the question paper. So this was a 2018 question paper. Okay. Let me just connect these dots over there. Né? When the volume was 50, the average rate was just 4.4. So 50 is over there, and then 4.4 will be there. And then when the volume was 40, the average rate, it was 3.5. When the volume is 30, the average rate was 1.7. 1.7 will be there. Then when the volume is 20, is it 1.7 as well? I think wrong lah. When the volume is 20, yeah, it was 2.6, then 1.7. Okay, when it was 30, the average rate is 2.6. And then 20, I now have 1.7. And then for 10, I'll simply have 0.9. So this will be our graph over there. Né? This line should touch at least 3 points. So that will be the graph of average rate versus the volume of sodium thiosulfate. Okay. And then now they want us to use the graph to determine use the information in the graph to answer the following. Determine the volume of the dilute sodium thiosulfate solution that needs to react in order for the cross to become invisible in 40 seconds. 40 seconds. What is 1/40? That's 0.25. So in 40 seconds, my average rate of reaction let me check the information properly there. Mm, 1/22.7. This will give me. Oh, so I just have to say 1 divided by 40. Okay. Oh, so 40 seconds, the average rate will simply be 2.5 times 10 to the power negative 2 per second. So this will be the average rate. Né? So I must go to 2.5 and then check the corresponding volume. Let me use a different color. 2.5 is somewhere here. and then the corresponding volume is there. So anywhere between 30 cubic centimeter, anywhere between these points over there. So I'll just choose 30. So the volume will simply be 30 cubic centimeters. 30 cubic centimeters. And yeah, it makes sense, guys, because over there in experiment 3, when the volume was 30 cubic centimeters, the reaction reached completion at 38.5. Yeah, so my volume must be closer to that one, yeah? Slightly above 30 actually. It must be slightly above 30. Do I need to go back there? Use the collision theory to explain the effects of increase in concentration or on the rate of reaction. Okay, once you increase the concentration, guys, you will have more particles that will be added in the solution, and hence there will be more effective collisions, and that's why the rate of reaction will definitely increase. An increase in concentration will increase the number of particles in the reaction, and hence will end up having more effective collisions, and that's why the rate of reaction will increase. The mass of sulfur produced in experiment 1 is 1.6 grams. Calculate the mass of sodium thiosulfate in experiment 1. Okay, firstly I want to know how many moles of sulfur have I made. What's going on now? Okay, the number of moles of sulfur that were created, that's mass all over the molar mass, that's 1.62. Sulfur has a molar mass of 32. So 1.62 divided by 32. This will simply give me 50625 moles. Right, together. I don't want to round off yet. I'll round off my answer at the final stages. The reaction rate. What's going on now? This thing of mixing papers. Now the information is gone now. I don't see my graph now. Okay, it's fine. But the chemical reaction, guys, for sodium thiosulfate, it's Na2, and then I have S. Let me confirm. S2O3 plus HCl. This will give us sodium chloride plus sulfur dioxide as well as sulfur. I will have a 2 there and a 2 over there. Let me check that everything is balanced. Yes, it is. Okay. I'm looking for I'm looking for the mass that was used for sodium thiosulfate. Okay, since I now know the number of moles of my sulfur, I can simply find the number of moles of my sodium thiosulfate. Since, guys, the ratio is simply 1:1, I can therefore conclude that therefore the number of moles that were used on my sodium thiosulfate is basically equal to the number of moles of sulfur that were formed, because the ratio is just 1:1. Are you together? Now I do know the number of moles. All I have to do is to calculate the what do they want? The mass of my sodium thiosulfate. So number of moles is equals to mass all over the relative atomic mass number. The number of moles is 0.050625. I don't know the mass, but the molar mass, Sodium is 23. Since I have two of them, I'll say 23 times 2. Sulfur is 32. Since I have two sulfurs, I'll say 32 times 2. Then oxygen is 16. Since I have 3 of them, 16 times 3. So therefore the mass will be equals to 0.05062 multiplied by 23 times 2 plus 32 times 2 plus 16 times 3. And this will give me a mass of 7.998, which is just 8 grams. So the mass of my sodium thiosulfate, mass of sodium thiosulfate is basically 8 grams. That's how, guys, we're supposed to tackle that question over there. I can see that, guys, now the information is mixed up because I was moving from one document to the other. But I really hope that I helped you out. Yeah, so just stay tuned, guys, and wait for more videos. Thank you.